Hey guys, Mr. Gran here with a functions review for the functions test in Algebra 2. The way you should use this, pause the video when you see the problem, try it on your own, and then unpause when you're ready to see the key. All right, so our topics for this test are all right here. If you want to pause it, you can use this as a little checklist to make sure that you know everything. What you would do is as you're going through the review materials, let's say adding functions, right? I know I can do that, check it off. But maybe composition of functions. That one I'm still a little hazy on. Put a little question mark by it or something like that. Go back to it, make sure that you have covered that topic, that you've tried some problems until you know for a fact that you can change that little question mark to a check mark. All right, so first question, domain and range given a table of values. All right, so the domain is always the x values, and when it's a list like this, we'll use a curly bracket. Try to do these in order, right? The lowest one is a -3, then a -1, a 0. Don't list the 0 twice. We're only concerned with the numbers that are present, not how often they're present. And the highest one is 2. Put a comma in there too. Range, same idea except with the y values. So our lowest one is -2, then 0, 1, and 4. Oofda. Comma 4. Like that. All right, domain and range from a graph. Now for this one, we're still talking x values for the domain. The way I like to think about this is what is the furthest left that the graph goes? And where does that correspond to the x-axis? What is the x value of that, right? In this case, it would be -3, and I'm putting a solid circle because it's got the solid dot. And then how far to the right does it go? It goes over here to 6. And now it's a solid line in between, so it's kind of like everything in between. Now, how we would describe this number line using interval notation, the -3 gets a bracket because it is included, and the 6 gets a parenthesis because it is excluded, because it has that open circle. All right, with the range, it's the same idea, except now I'm talking about the vertical component. So first off, how low is the lowest point? What is the height of the lowest point? That would be down here at -2. So for the range, open circle, so that gets a parenthesis, -2. And then going up to right here is the highest point, closed circle there, at +4. So that gets a bracket. All right, is this a function, yes or no? And explain why or why not. Anytime that we're doing these, we've got inputs and outputs. Those are x's and y's. So I'm just going to change that to an x and a y. This is a yes. It is a function, and the reason is that the x values do not repeat. If you have more than one input with different outputs, then you know that it's not a function. Okay, determine whether each relation is a function. Explain why or why not. This is our vertical line test. So if I make a vertical line, it doesn't matter where that vertical line goes, right? That purple line, I can move it around now. And it doesn't matter where it goes. It's only ever going to cross this graph one time. That means that this is a yes. And we could say it passes the vertical line test. All right, evaluating functions, just plugging in numbers. All we need to do here is plug in the -3 in for all of the x's. Now, With negative values especially, be sure if you're using a calculator to put that in parentheses. If you don't use parentheses and you do -3 squared, it's going to give you -9. But we know that a negative times a negative is a positive, so that should be a +9. Then this becomes a +12 minus 6, and that gives us what, 15? 0, always a nice one to plug in because it just cancels everything out. So a lot of us don't even really need to write this out because we know that wherever there's an x, if you plug in a 0, that term goes away, right? And so what we're left with, 0 minus 6 is going to be -6. All right, evaluating the function on the graph, using a graph. So f of -3, that means the x value is -3. So the first thing I want to do is identify where is the x value -3, and I want to know what is the height of the graph, what is the height of that red line directly below 3, right? And so if I go over, the height there is -4, that means the value of the function is -4. F of 0. Now, where is x equal to 0? Right in the middle. So now from the middle, I just got to go up or down. In this case, up. So if I go up, what is the height there? That is a height of +4. So f of 0 is 4. All right, is the inverse a function and why? Oops. This is a no, and it's because it fails the horizontal line test. Oh boy. There we go. And it fails the horizontal line test because that horizontal line that I plotted on there crosses at 2 points. So the inverse is not a function, and that is because of the horizontal line test. All right, adding and subtracting functions. Now, we're doing these with polynomials. It's just combining like terms, right? So for the first one, adding them, 3x squared plus 5x minus 4 plus a -4x, so I'm not changing the signs of anything. And I'm just combining like terms, right? So which ones match? I've got x's that can combine. I also have just plain old numbers that can combine. And then I've got to square it all by itself.
Good afternoon, everyone. Please excuse this brief interruption. B-Day students, we wanted to make sure that you were aware that next week, March 8th through March 12th, Student Council is hosting a food drive. You can drop off items before and after school in the east and west side entrances, as well as during lunch. It's an academy competition, so we will tally points based on how much you bring in. Each day there will be a theme. Monday is canned goods. Tuesday is COVID-19 items. Wednesday is box items. Thursday is hygiene products. And Friday is everyone's favorite toilet paper. If the item you bring in matches the theme for the day, it will contribute more points to your academy. Can't wait for all of your participation. That's everything I have. Have a fantastic weekend. Please wait for the bell.
All right, so that will be funny that makes it onto the video because I'm not redoing this. Okay, so when we're subtracting, right, now I'm putting them in parentheses just so that I know that this second one, as a reminder, that I need to distribute the minus into the parentheses and change the signs. So the first one, the signs don't change. This one, the signs do. And then it's just the same as the addition one, right? We're just combining like terms. So where are like terms? Again, it's going to be our x's, and it is going to be our plain numbers. And so this will result in a very similar looking answer, 3x squared. The x's become 9x, and then -4 minus 7 is -11, like that. All right, multiplying functions. With these ones, now you could use box method here. I'm going to use FOIL just because it's It works a little bit better for me with the amount of room that I have, but it doesn't matter. So stack them next to each other if you're doing it this way. Now I can FOIL either direction, right? I can take this x minus 2 and I can start by distributing the x backwards into that parenthesis, and that gives us x cubed minus 5x squared minus 3x. And then I'll take that negative 2 and I'll do the same thing. I'll distribute that to all three terms. And that's going to give us minus 2x squared plus 10x and plus 6. Now we're combining like terms. I've got squareds that will add together. I've got x's that will add together, and then I've got some stuff that doesn't have anything to combine to. And so my final answer, x cubed, negative 5 minus 2 is minus 7x squared, negative 3 plus 10 is plus 7x, and then the plus 6. All right, evaluating composed functions. So the big thing here, remember, plug in what's on the inside first, right? Work your way outward. So the first thing I'm going to do is plug in that negative 4 into the f, right? So f of negative 4 is going to be negative 4 squared plus 5 times negative 4 plus 3. I can calculate all of that. Negative 4 squared is 16. That makes a minus 20 plus 3. And that gives us what? Negative 1. All right, now I now want to take negative 1 and plug it into here. So then I will do g of negative 1. And that is 5 times negative 1 plus 7, which is negative 5 plus 7, which is positive 2 for the final answer. All right, let's get rid of all of this. Now, same thing, only backwards for find f of g of negative 2. So I'm going to start out by plugging negative 2 in here. G of negative 2 is equal to 5 times negative 2 plus 7, which is negative 10 plus 7, which equals negative 3. Now I'm going to take that negative 3 and I'm going to plug it into f. Wherever there's an x, I'm going to plug it in. So f of negative 3 is equal to negative 3 squared plus 5 times negative 3 plus 3. If I start simplifying this, negative 3 squared is 9, minus 15 plus 3, and that also equals negative 3. All right, compositions of functions. Now, this one's got a typo on it, and the key has a typo too. If you look at the key, the answer to this one is listed down here, and the answer for this one is listed up here. They got switched around somehow. Okay, so g of f of x. What this means is I'm taking the equation f of x, I'm taking this, and I'm plugging it in for x in g. All right, so what this equals is, instead of 2x minus 1, it's going to be 2 times the equation, negative 2x squared minus 3 minus 1. So all I've done is I've replaced this x with this equation in a set of parentheses. Now we can simplify this, distribute in the 2, and we get negative 4x squared minus 6 minus 1. And then combining like terms, we get negative 4x squared minus 7. All right, next one. Same idea, except now we're going the other direction. So it's g of x, the equation g is going to get plugged into the equation f. So I'm going to take this and I'm going to plug it in for that x. That's going to give us -2, and x is now replaced with 2x minus 1 in parentheses. X gets squared minus 3. This one's going to have a few more steps to it because we have to square that binomial. So -2 times 2x minus 1 times another 2x minus 1, and that minus 3 on the outside. We can FOIL, or if you prefer to box method, it's fine. You can do that too. That is -2. When we FOIL this out, it is 4x squared minus 2x minus 2x plus 1. And then there's still that minus 3 at the end. We've got some like terms that can combine. 4x squared minus 4x plus 1. Now I can distribute that -2 into all three terms. That will be -8x squared plus 8x minus 2, and we still have that minus 3 on the outside. And so my final answer there, when I put all of this together, see if I can fit it on here, -8x squared plus 8x minus 5. And we'll highlight that one since I don't have a ton of room. That's our answer. Right, inverse functions. So remember that f of x, this is really the same thing as y, right? And so the first thing that we want to do is switch x and y around. So it's going to be x equals -4y plus 5. Now we want to convert it to a normal equation where it's y equals and the other stuff on the other side. So now it's just some algebra rules, right? -5 on both sides. And we get x minus 5 equals -4y. Now we can divide both sides by -4. And you might be able to just keep it like this and just cancel out the -4's and say that it's x minus 5 over -4. We could also simplify it further, like we did with linear equations. Remember that the -4 is dividing both terms. And so that means that we have -1/4 x plus 5 over 4 equals y. So it could be either of these formats. Might be good enough just to do it to here, but you can also simplify this into a linear equation. All right. Next one. Same idea. We want to treat g of x, this is really y. And now we'll switch x and y, so it's going to be x equals 2y minus 1 over 4. To start this, make a better looking 4, I need to multiply both sides by 4. That will cancel out the 4 from the denominator. So now we have 4x equals 2y minus 1. We can add that 1 to both sides, and we get 4x plus 1 equals 2y. Again, I want to get rid of that 2. And I could either maybe leave it as 4x plus 1 over 2, or if you want to go the extra distance, we can simplify it. 4x divided by 2 is 2x. 1 divided by 2 is 1/2 equals y. All right, 2 more slides. Write the transformed equation and then describe the transformation. So what we're going to do here is, again, the stuff that's in the parentheses, that's what you replace x with, right? If it's x squared, we can plug in an x minus 3. So this will now be x minus 3 squared. And what's on the outside was the plus 4. We need to add that in. And now we can simplify this. So x minus 3 squared is x minus 3 times x minus 3. No, it's not x squared minus 9. We'll FOIL this stuff out. And we get x squared minus 3x minus another 3x plus 9 plus 4. And now we're just combining like terms. X squared minus 6x plus 13. All right, so that's the transformed function. What is the description of that? The minus 3 on the inside of the parentheses, remember, is horizontal. Minus moves it to the right, so this would be right 3. And then outside, that's our vertical visitor. That is up 4. All right, now our transforming a graph. I really want to focus on this on the vertex, right? This point where the two lines meet in this absolute value function. Basically, I want to think about where that point moves, and then I can just sort of sketch the two diagonal lines from there. So x minus 3 for letter A, that is going to move to the right 3, so that vertex moves 3 to the right, and then the slopes going away from it are just up 1 over 1 for both of them, like that. So that's the purple one. I'll do the next one in red. So f of x minus 4, that is a down 4. So we can take the vertex of the original, move it down 4, and then draw our lines. And then the last one, I'll do that one in green. Do it dark green. So we got a lot of stuff going on there. We have a vertical reflection, a shift 2 to the left, and then down 1. So let's move the vertex first. 2 to the left and down 1 from the origin is right there. And now, because of that vertical reflection, instead of going up and to the right, up and to the left, it's going to go down to the left and down to the right. So it's upside down. All right, that is everything. Let your teacher know if you have any question, and good luck on the test.